In the dictionary, the word curious is defined to mean something which is puzzling or surprising or unexpected. And this demonstration might seem rather puzzling at first until we realised that the cylinders were not empty at the start. Each of them had a little speck of chemical which reacted with the liquid in this container, and it produced a colour change. We'll look at the chemistry of that in just a moment. Let's have a look at the liquid in these two beakers. They're both colourless, but let's see what happens when I pour the liquid from this beaker into this one. So again we see a colour change. It's turning blue. The blue is getting darker. And as I keep pouring, it goes away again. That's also rather odd. It seems as if a chemical reaction began and produced a colour change, and then it sort of changed its mind and went backwards. So did it go backwards? Did that chemical reaction go backwards? So the chemistry of these demonstrations is based on a simple idea, which is that every substance can be thought of as either an acid or an alkali. And if it's neither, if it's sort of in the middle, we say that it's neutral. Now, we can use certain substances to tell us whether a material is acid or alkali, and probably one of the most famous of these is called litmus. So litmus is a material which is red in acid conditions and it's blue in alkali conditions. But there are lots of other indicators, and the one we used in this experiment was called universal indicator. So this has a range of different colours. It's red when things are strongly acidic. In the middle, where things are neutral, it's green, and in strongly alkali conditions, it's purple. And this experiment was based on an indicator called thymolphthalene, which is colourless in acid and it's blue in alkali conditions. So these cylinders had different amounts of acid and alkali in them, producing the various different colours. In this experiment, the first beaker had a mixture of thymolphthalene and some acid, and the second beaker had some alkali. And the key to this is that when acid mixes with alkali, they react to produce a salt plus water. So they're sort of opposites. They kind of cancel each other out. So as I started to pour the liquid, the acid and thymolphthalene from here went into the alkali, but the alkali quickly cancelled out the acid, so the thymolphthalene is now an alkaline solution and it turns blue. But as I keep on pouring, I'm adding more and more acid, it's neutralising the alkali, and eventually this beaker becomes acid as well, and the thymolphthalene goes back to being colourless. So this reaction was not going backwards, it was just the same reaction all along. Well, we could ask, is there a chemical reaction that goes backwards? Can chemical reactions go backwards at all? Well, that turns out to be a really interesting question, and it's a question that we're going to come back to several times during the course of this lecture. But let me just show you now another example of a reaction involving universal indicator, and it's this column of water which has universal indicator and also a little bit of sodium hydroxide, which is alkaline, and so it's turned it this sort of bluey purple colour. And we're going to add some acid, and we should see it go through a sequence of colours rather like these. Now the particular acid that I'm going to use is acid that's going to be made in the water from carbon dioxide. So in this beaker I have carbon dioxide, but it's frozen. It's at minus 79 degrees centigrade. It's become a solid. We call this dry ice, because when it warms up it doesn't melt to a liquid, it goes straight to a gas, so it's always dry. So when I add the dry ice to the water, it will react with the water to form an acid called carbonic acid. That's the same stuff that's in fizzy drinks. That's what gives the fizzy drinks their fizz. So let's see what happens when I add this. Now watch for the colour changes. You should see that sequence of different colours. Okay. So in all the reactions we've seen so far, we mixed two things together. It produced a chemical reaction which gave rise to a colour change. So let's have a look at this flask. This flask has a colourless liquid in, but if I shake the flask, it turns blue. Now, that's a bit surprising because I didn't seem to be mixing two things together. I was just shaking up a single liquid. Here's another flask. It's a similar idea. This is a yellow liquid. If I shake it, it turns red. And if I gave it a really good shake, it turns green. Now, something else rather surprising about this as well. If we keep watching, the green is turning back to red. And if we look here, the blue is turning back to being colourless. In fact, the red will go back to being yellow. So it's going back through that sequence of colours again. And what's more, I can even repeat it. So if I shake it again, it goes back to being blue. If I shake this again, it goes back to being red, and so on. And if I wait, it will go back. So again, it looks as if we have a chemical reaction that's going backwards. But the first mystery is, why do we have a colour change at all? I didn't seem to be mixing two things together. What we have to remember, of course, is that this flask not only contains water, but it contains a gas. In fact, the gas is just air. And air, of course, is a chemical. And when I shake the flask, I'm mixing oxygen from the air with the liquid, and that's producing the chemical reaction. So the next question is, did this chemical reaction then go backwards as it fades from blue to colourless? Is it a chemical reaction that's going backwards? Well, unfortunately, it isn't, because what's happening is there's a second chemical reaction taking place. This flask contains a dye called methylene blue, and when it reacts with oxygen, it goes from colourless to blue, but also in the flask is some glucose, and that glucose slowly turns the methylene blue from blue colour back to being colourless. And this is the same idea, but with a different material called indigo carmine. So again, we didn't have a chemical reaction going backwards, but we're going to keep on looking for such a reaction as we go through the lecture.